What's up, everybody? Welcome to this practical mini course on PineScript version 5. Now, I value your time and attention, so I've created this course specifically tailored to be the quickest way to learn PineScript. It's going to take you from beginner to advanced. We're going to learn syntax, variables, plotting, loops, arrays, matrices. We're not going to go so deep into the details. The whole point is to get you up and running practically and efficiently, so you will be able to determine if PineScript is right for you. My name is Paul. I've been trading and coding with PineScript since 2015. Now, I'm here because I genuinely like helping people, and I want to be transparent with all of you. You won't find any misleading content from me online, as it goes against what I believe in. And what I believe in is that the best way to make the world a better place is to educate people and to help them become financially free. Because when more people are educated and financially secure, our communities thrive because those in power have less control over us. So that's what I want to see for you and for everyone, really. So that's my mission here. So many of my students that I've had in the past who have taken my courses have gone on to be successful, and they've created amazing indicators, amazing strategies, and I hope for you that will be the same. Lastly, this course is also available on my website, pinescriptstrategy.com. Now, why would you go to my website for this course? Well, there's more content, there's more videos, there are quizzes, there's a way to track your progress, and you get direct access to me. Now, it only takes 30 seconds to register for free, and then you'll be on your way, and I promise you it'll be worth it. So go ahead and do that if you'd like. If not, you can continue following along in this video, and I will see you in the course. What is PineScript?
PineScript is a domain-specific language developed by TradingView. It creates custom technical analysis indicators and strategies within the TradingView platform. Its main goal is to allow traders and developers to very quickly and efficiently create these personalized tools, alerts, and trading strategies to help them make informed trading decisions. What are the pros of PineScript? You don't need to download any special compilers, any special software or tools onto your computer. PineScript operates entirely in the cloud. You don't need to maintain your own server or your own data feeds, connect to APIs or anything like that. It all just works. This is very time-saving and convenient. You can load it up on your phone or on your computer, wherever you are, as long as you have an internet connection. And the charting and the analysis software is very powerful. You can set up automated trading strategies. You can backtest, forward test. You can buy and sell. You can send out webhooks to connect to other things. And you can set up custom alerts and notifications. Now, what are the cons of PineScript? One, it's in the cloud, so you need an internet connection. And two, you're limited to just TradingView. You can't port PineScript over to something else and run it somewhere else. However, with that being said, PineScript is very similar to other languages like JavaScript and TradeStation. It shares some similarities. With the knowledge you gain here, you can transfer it to something else. Or you can just hire another developer to take your script and convert it to something like Python or JavaScript if you want to run it on your own server. So overall, PineScript empowers traders and developers like you and me to create custom technical analysis tools, automated trading strategies, all while benefiting from the convenience of a cloud-based infrastructure and the comprehensive capabilities of the TradingView platform. In this video, I'm going to teach you guys how to set up and use PineScript inside of TradingView. So it's pretty simple. We're going to go through a list of steps, and then by the end of it, you should have some script running on your chart. Now, the first thing you need to do is go to tradingview.com, and if you haven't done this already, make an account. And you can make a free account. You don't have to pay for anything. And you can also use a referral link I'll post somewhere in this video, and we'll both get a bonus. Once you have an account, and if you're still on the home screen, it might look something like this, or maybe TradingView automatically directs you to a chart. It's going to change from time to time. But once you have an account, you're going to want to navigate to a chart. So the way you do that right now is you can launch the full chart view down here, and it brings up a chart. You can go over here and select your symbol. Just pick something that you're familiar with. It doesn't really matter. Whatever symbol you want. Apple. Okay. Now your chart's not going to look like mine. So if you want to make it look like mine, you could come to my profile, and I'll leave a link for that too. Or anybody's profile, any chart you like. Click on one of their ideas, and then you can come down here to share, and then make a copy, make it mine. And what it's going to do is going to grab everything on my chart, and you'll get the same template I have. So your chart will look like this. Okay? Once you have that all done and you got your chart all set up and it looks good, you can come down here to the Pine editor. And you open that up, and it should look something like this. They're going to have some default template code in here. And this is the name of your script. You can go ahead and name it there. My script, press save. This is how to rename it. You can star it to add it to your favorites. And you can check the versioning of your code. So when you make edits to it, you can go back and go to an older version or a newer version. Now the way to make it work is just add it to the chart, and there we go. Now it's on the chart. So it's very simple, and that's all you need to do to get PineScript up and working. And when you make changes, say you want to plot the open as well, you need to save it and update it to the chart. And now it should be plotting the open as well. See, now there's two plots there. And if you want to change from this to have it plot up here, because there's two places it can plot. There's a subpane and there's the main chart. This is the subpane and this is the main chart. If you want to change that, you just come to here and you select overlay and you press true. Now we're going to go more into detail on these things, but just to get you up and running, click save, and notice how it didn't change. You need to actually remove it from the chart and then re-add it to the chart for that specific change to take place. Only for that one, okay? So now you can see here, the script is now here, my script, and it's plotting the open and the high. And then you can turn it on, turn it off. You can go to the settings for the script. And then if you want to go back to the code, the source code, it'll pop it up right there. And then you also have in here, if you press open, you can go to templates they built, indicator templates, strategies, libraries. And these are just boilerplate templates. And then they have built-in scripts that you can check out. And then these are all your scripts. I should say my scripts. The stars are the favorited ones. Those will go right to the top. You can filter by script name, date modified, and search through them. And then if you're looking for open source scripts, you go to TradingView and then you type in scripts. And this is where you'll find all kinds of ideas and different kinds of scripts. Or you can search inside of indicators here, and you can find scripts in here. You get my scripts, technicals, financials, community, invite only. Some of these are closed source, so you can't access the source code, but most of them are open source. That's how you get set up with PineScript, and in the rest of this course, we're going to be going into much greater detail. See you in the next video.
In this video, I'm going to add a script that I've created to the chart, and then we're going to make sure you can do this so it works correctly on your chart.
So the script is called Hello World, and it's a text file, so it opens it up in the text editor. Just go ahead and Control A, Command C, copy it all, right? Open up the Pine editor, create a new indicator like this, and then you can copy all here and delete it. Make sure you're starting with a completely empty script, and then just paste this script in. And you'll get something like this, okay? And just save it, Hello World. I'm gonna call it delete so I know to delete this later. Call it whatever you want, and now it's saved to your scripts. And then we're gonna go and add it to the chart. And you should see something like this. And if you just move your mouse over, you do this so that the bars end up like that. You can scale it, you can double click this to scale it like that. And then you should see something like this. And congrats, you've added your first script to TradingView. Now you can go ahead and play around with this code if you want, or you can meet me in the next video. In this video, I'm going to show you guys how to backtest almost any indicator very quickly with one strategy. So I won't go through every single step that I took. We'll do that later on in the course, but I'm just going to show you so you can get excited about it, because this will save you so much time. So what I did is I went to the scripts URL and I just found one of these scripts here that was trending at the time, called Reversal Signals by LuxAlgo, updated June 15th, 2023. And I don't know anything about this script. I'm not affiliated with these guys, but it seems to be pretty popular. People like it. It looks well done. So what I did is I grabbed it, and the way that you grab it, let me just show you how I did that. So you come down here, you can copy the code, or you can add it to your favorite indicators. Let's just do that. So I copied the code. Now I could come in here, create a new indicator, remove the code, and then paste the code in. That's one way of doing it. You could save it, and then now I have the script, right? The other way of doing it, you saw me add it to my favorites, and I have a lot of favorites here. It would be under LuxAlgo, this one right here. So you come over here, and then you add it to the chart, you click on it, and then you go click on the code, and you see here now it says this script is read-only. You can just create a working copy, and it does it like just the exact same thing as copying it and pasting it and doing a script. Now I go to save it, and you can tell that there's already one in there. I'm going to save over the existing script. Now that you have the script, you might have noticed that this is an indicator, and I said we're going to be backtesting this. Now, depending on how familiar you are with PineScript, you can't really backtest indicators unless you know things. So what I did here is I turned this indicator into a strategy without converting it into a strategy. And what I did is I found the signals that were useful to me by looking at the alerts, and I found the conditions that basically said buy or sell. And judging by this P, which is green, so that to me indicates it's a good buy area, right? And if you go and you open up this thing right here, this is called the data window, you can see the data that's coming out of this script, LuxAlgo reversal signals. So when I hover over every bar, the data changes for that bar. So what I found is when I hover over this P, I get a 1 pop up right there. Perfect bullish momentum phases. Right there it pops up, and then when I hover over this red P, the perfect bearish momentum phases pops up as a 1. So I can tell you right off the bat that these are being triggered obviously by some code inside, and there's a 1 that pops up. So how do I find these in the code? All I did was type in perfect bearish momentum phases. So I open up the Pine editor, and you can do this. You can use this search, or I use Command F or Control F if you're on Windows, and then just type in perfect. There's perfect bullish momentum phases, and this is plotting the shape, the P, every time that condition's true. So what I did here is I just grabbed this, I copied it, and I scrolled down to the bottom, and I made a buy condition. And I did the same exact thing for the bearish one. So I typed that in, perfect bullish, and then see as 1 out of 2, now it's 2 out of 2. Perfect bearish. And I just copied it all the way to there. Make sure you don't grab that comma. And then I did a sell condition. And that's exactly how I got these signals. And then I created a signal, and I did buy condition, send out a 1, sell condition, send out a -1, else, send out nothing. And don't worry if you have no idea what's going on, you will learn. Oh, here we go. Missing this, that should go there. Okay. And then the final step I did was just plot that signal. And if you want all this without having to type it out, you can just go here to pinescriptstrategy.com. I'll leave a link for this. Go to the presets and then click on reversal signals, and then you can copy this code right here. And you'll see I have the same exact thing all the way at the bottom, just like that. That's the only thing I changed. Okay, and now we will backtest this by saving this code we just wrote. Okay, and we need to download one more script. So the other script is going to be the strategy optimizer. Where is it? This one right here. So I will leave a link for this one as well. You can get it here. You can also get it on my website, strategy optimizer, right here. I'll leave a link for that. But go ahead and just add that to the chart. And this one is a strategy. This one's an indicator. We can feed the indicator by clicking the settings and going to external source and then finding the signal. Where is it? It's not popping up for some reason. And maybe that's because this is not the one. This is the one I added after, and then I made a copy. I didn't add the copy to the chart. Oops. Let's go. It was this one. Make sure you have the right one added to the chart. And then I got this error. Maximum number of output series 64 was reached. Script contains 65. That's one of the limitations of PineScript. You can't have more than 64 plot outputs. I fixed that in this code, but I'll show you how I fixed that here. All I did is I went down to a plot function, any which one you want, and I just removed it. Command comment, command slash, control slash just removes it. So now I only needed to remove one. Save, and okay, it's working now. Took a second. Good, there it is, it's working. Now, let's go to here again, and then the signal just popped up, because now we have the right script. And then you don't have to do anything else. Okay? So we'll just go up to the 1 hour, and you can see now we have some information over here in this trade window. You can also go to the strategy tester here and get a more visual overview of what's happening. You can check performance, the list of trades it's taking, and on the S&P 500 it doesn't seem to be doing too well, but that's not to say it's a bad indicator. Maybe we're not using the right signals, or we're not using the right risk to reward ratio. We can have no stop loss here, and just by default trading view, when it gets an opposite signal, it will flip that position, so we're always in the market just going back and forth. That's what this does when this is on. So I took the stop loss off, and now it's just going to be flipping back and forth between buy and shorts. So it's still not making money on the daily, not making money, but we can change it to maybe the S&P 500 is not good with this, not good with this one either. So that's a really quick way to test strategies. Seems to make a lot of money on XLM Stellar, gross profit 80,000. So like you can walk through all your coins, and this isn't the best way to verify if it works. It's just to give you a good idea. Okay, this strategy seems to be working well on Stellar. I don't know specifically. I just grabbed this indicator off of the trading view scripts. I quickly converted it to a signal generator. Then I fed it into the strategy optimizer, and I just picked the simplest thing I could do, just straddle back and forth. Okay, and that's how you do that. That's how you quickly test almost any indicator. I hope this was informational. I hope this helped you guys. So if you want more presets so you don't have to code anything up, you can just go right to here, and if you have a request, I can create the preset. It takes me all but 5 minutes. I'll post it up here, and then you'll have whatever indicator that you find on TradingView just ready to go in the optimizer. All right, so see you in the next video. Let's explore the difference between indicators, strategies, and libraries. Indicators are the most common type of script you will find on TV. Formerly known as studies in version 4 and earlier, they are faster and more efficient than strategies. Indicators are used to analyze price data and generate visual representations on a chart. They help traders identify potential entry and exit points, trend directions, overbought or oversold conditions, and other relevant information. They also provide alerts for manual trading decisions. Indicators are typically plotted on the price chart or in a separate subpane indicator below the chart. In PineScript, you can create custom indicators by defining calculations and plotting functions using the indicator declaration in version 5 and above. Strategies. Strategies are used to automate trading decisions based on specific conditions and rules. They generate buy-sell signals and manage positions based on predefined criteria. Strategies can execute trades automatically or provide alerts for manual trading decisions, just like indicators. In PineScript, you can create custom strategies using the strategy function. Strategies have access to historical price data, can generate trading orders, and manage positions. Finally, we have libraries. Now, libraries are new to version 5. Libraries are reusable code modules that contain functions, calculations, or other utility code that can be shared and used across multiple scripts. Libraries can provide commonly used calculations, mathematical functions, trading algorithms, or other functionality to simplify script development and enhance code reusability. In PineScript, you can create custom libraries by defining functions and utility code that can be imported and used in another script by just using the import keyword for that library. This is new to version 5, and there's already a lot of new libraries you can use. In summary, indicators are used to visually analyze price data on a chart. They're faster. Strategies are used to automate trading decisions based on predefined rules, and libraries are reusable code modules that provide functionality to simplify script development and enhance code reusability. Each of these components serves a different purpose, and you may often find yourself using all three of these. Alright, so in this video, we're going to cover the syntax, structure, and other stuff of PineScript. We're going to be going over all the fundamental concepts in PineScript, and you're going to get to see everything that works in PineScript right now. Right now, you should have this script loaded up on your chart as well, and it should look exactly the same as mine, so we can kind of work together. And at the top of every script, we will need a version directive. And this is the version directive right here, this thing, okay? And this basically tells the compiler of what version to use. And we can change it to 4, 3, 2, 1, but we'll most likely get an error because version 1 doesn't include a lot of the features that are in this version 5. If you remove this, you're going to get some errors because by default it uses version 1. If there's no directive there, it will use version 1. And that might cause you some problems and some headaches, so keep in mind to always have this, and on version 5 is the best one to use for now. Variable declarations. Now, if you have a value and you don't want to keep on typing that value, so I have 1 and I want to use it everywhere in my script, I don't need to type in 1. I can just assign it to a variable like this, and then I can use this instead of 1, and this will always contain the value of 1 as long as it doesn't change. Now, the variable names are case sensitive and they must be unique. So if I want to assign something else to this my var, I'll get an error. So let me save that, and then it sees error at 27.1. My var is already defined. So if I want to reassign something to my var, I actually do this, the little walrus face, and that will make it work. I can access different historical context of the variables by using this history operator, and this will just give me the previous value of that variable. Doing that, and all variables are dynamically typed, which basically means that you don't need to assign the type of value that's being assigned to that variable. So what that means is this 1, that's an integer. This 2 is an integer. This is now a float. We also have booleans. This is an integer. It's just exponential notation, so it's to the 3rd power. This is a string. This is an integer. It's a built-in for the index, which shows me the bar count. and this is an input, which is an integer as well. So you don't need to do that, but you can. And that way, see, it's giving me an error because that's not an int. That's a float. And this is an int. You can do it on the left side, or you can use this here if you want to recast some type of value. Say this was a float to start with, and you want to cast it as an int, you can do that as well. You don't need to do it, but it's nice to do so you understand your variables better and you don't run into as many errors, because there's some functions later on we'll get into that require a certain type in order for it to work. You also have user-defined types. You can create your own types. You're not just limited to these 5 fundamental types: int, float, booleans, colors, and strings. And then there's special types: line fill, label, box, and table. And that's variable assignments, reassignments, even historical context. And that's pretty much how you work with variables. We'll get into more detail here in a second. All right, let's talk about line wrapping, because it's your time to shine in the line light. Now this is a long line, line 46. It extends beyond my little window here, and there's other values, and that's okay, it works, but maybe I want it to be more readable, and that's what line wrapping is all about. So the way to do that is, for each parameter, you can put it on a new line. And I'll just go here, I'll go to this comma, because this is what separates the parameters, and I'll click return so it drops down to a new line. Now the key here is that this new line needs to be indented in. Any variation of a space that is not divisible by 4. So what that means is I got 1 space, 2, 3. If I do 4 here, it's going to throw an error. 5, 6, 7 works fine. And you see this little gray line, that's very helpful because it shows me that I'm not on the mark. So I can do that, I can save that, and I won't get an error. But if I do this, I save it, I have a syntax error at input, end of line without line continuation. Pay attention to that, because that's going to happen to you a lot. And it's going to, when you click it, it's going to bring you up here. It won't show you that your error is actually right here. So now if I want to finish my line wrapping, I can line it up with this series so it looks nice and neat, however you want to do it. And now, from now on, every time I press enter, it's going to line up with the previous line. And then now I have this beautiful line wrapped. I can leave this parenthesis here, or I could bring it down here. The last line doesn't need a comma. And we're good. There's line wrapping. Okay, now let's talk about the operators that are available to you in PineScript. You can do arithmetic, comparisons, and logical operations in your expressions. When you assign a value to a variable, or you can use the values in themselves in your equation to operate on them, like a docta. Okay, so you see here I've assigned 1 to A and 2 to B, and for this variable C, I can do A plus B minus A. This is a times B divided by A plus, and then you can use parentheses. Everything in PEMDAS you can do. And then further, let's see, let's plot that. Let's plot C first, and let's see what that looks like. And we have here C, so apparently this is 2. It should be noted that if you are using 2 integers and you do division, it's going to give you an integer. You won't get the float remainder. So if you're trying to do 1 divided by 2, in this case, imagine if I was doing A divided by C, or A divided by B, excuse me, you'd think that would be 0.5, but it's going to give you 1, or going to give you 0 in this case. Yeah, so it's going to round down. So it should be half, but it gives you 0. So keep that in mind. If one of these is a float, then it will work. So now I get 0.5. You also have comparison operators. So is C greater than A? If it is, then that would be true. I'm going to plot that, plot D. I'm getting an error there. Let me just show if that's true. Draw 1. If it's not true, show me a 0. It's not true in this case. There's other types. You can greater than or equal to, less than or equal to, and then not equal to. You can also do an OR gates for the AND. C and A would both need to be true in order for D to be true. Since C and A are integers, this does work, but you're better off using this type of evaluation when you're using booleans. In this case, true and true, then D would be true. But if this was true and false, then D would be false. If this was false and false, then D would be false. For those of you who don't know how AND and ORs work, this is how it works. So you have true or true. Then if either one of these is true, then D will be true. So in this case, D is still true because that's true. And obviously you can do parentheses. So it's going to evaluate the parentheses first. So A is greater than B, or A is greater than 0. We can see that A is 1 and 1 is greater than 0. So we know that's true. And we do B is less than or equal to 5. And since B is 2, we know that's true. But to verify, we'll plot the D, and we can see D is true because it's showing a 1 here. And those are your operators, and you can have fun with those. And let's talk about conditional statements, if-else statements, switches, ternary operators. These are things that will allow you to make decisions in your code. Now, what does that look like? Let's look at this little example right here. First, I've assigned this variable D to a boolean false. Now, I'm using the conditional syntax if here. I'm saying if the close is greater than the open, then go into this little code block here. And notice the indent here. This indent is actually 4 spaces. And this is fine being 4 spaces for the if condition. And then if this is true, then it will execute this code block inside of this. Now in other languages you might wrap this around with some parentheses or some semicolons, but you don't need to do that in PineScript. You just use the indentation here. So I use a tab, I bring it over. Now if this is true, then it will come in here and it will reassign D using the reassignment operator to true. And then we're going to plot it. But you might have noticed that we can't plot it because you can't plot booleans using the plot here. So we can just use plot shape instead. So I'll save that, and every time the close is greater than the open. Is that what I said? Okay. And you know what? Let's just make this easier, and we'll change overlay to true, and we'll remove the current indicator off that pane, re-add it to the chart, and now we get these shapes plotting above the bar. So here you can see the close is greater than the open. That's why we get this X, this character, but here it's not. So we get red bars. So every time there's a green bar, we get true condition in this case. Pretty simple if condition. You can have else statements within this if condition, and then you can do like else if, let me see, else if the close is equal to the open, D is equal to false. That's not very useful or practical in this case. But the idea is you can use these if else if, and then finally you could use an else. If none of these are true, then do this one is equal to false. The Boolean condition here isn't very helpful. So let's change that to 10 to an integer, and we're just gonna have to change this to, we could reassign it using the plus equals, so maybe it counts every time there is an open bar. Every time there's a green bar, it will count. So we'll change that to 0 instead. It's gonna count 1, and here it could just reset it 0, and then if not, we'll do a -1. So it's going to -1. And we can't use plot shape anymore, so let's plot D. Let's see what happens. And now we're going to get a different layout, -1. Alright, so all we're getting is 1, -1. Now why is that happening? Well, if you look here, when we made our initial assignment, D equals 0, we didn't make it a var. We didn't use this keyword, var. And because we didn't use that, every time the script executes on the bar, it reassigns, so it resets it to 0 every single time it hits a new bar. So it's only going to ever be 1, -1, or 0. So in order to fix that, we initialize D once on the first bar at the very beginning of the script with 0. And now it will hold the value across all the executions. And now it's counting up, it's counting down, we see the value moving across. More green bars than red bars in this case. Okay? And we can also use the ternary operator. We've seen this with the booleans. So if we turn this back to a boolean, which I don't feel like doing. So if we wanted to rewrite actually this using the ternary operator, we could do it like this. So D reassign as close is greater than open. If that's true, then D plus 1, that would count. Okay? And then else, if the close is equal to the open, and we could do this again, we can actually have a whole line of ternary operations where it checks this value now. If that's true, then we do 0, because that gets returned to this D. And then else, if this isn't true, else if, finally, we do -1. But it's D -1, so we want to return D -1. And that will be the same exact thing. So what do we got? We got 22 over here in the data window. And let's see, just remove this. And we got 22 as well. So that's how you would use the ternary operator if you want to write something on one line of code, or you can use the if-else conditions. Whatever works for you, I use them both all the time. And then finally, we have the switch statement, which is new to version 5. Let me just remove all this. And using the switch is just a little bit more complicated, but we're gonna do it right here. So what I've done is I've assigned 3 variables that I'm going to be using, and I'm using inputs to assign these variables. And I've also assigned the type as well, so it's clear. So this is a string, source, and int. And the source and this specific input just allows me to pick the close, open, high, low automatically from a drop-down. And then this string, I can create options here. So I've created 3 options. If you hover over it, you can see the default value is SMA, MA type is the title, and then options are those 3 options, SMA, EMA, and WMA. And then those, whatever I pick on the input gets assigned to this value, this variable here. And then here in the source, I only have just the default value and the title, and the integer, I just have the default value and the title. And that's assigned to length. And you can see those. If I save this, I will show you what it looks like. Oh, I get an error here. Where's that? Okay, let me just fix that. And I need an output. Every indicator needs an output. So let me plot this MA. Okay, so if I come to the settings here, you can see now I have MA type, MA source, MA length, and I get this drop down of those 3 options. And I also have the source, which it creates this drop down automatically for me when I use that input type. And then here's the length. Okay, this is what I did. I took these 3 variables here, and I'm testing. So switch, you put in the variable here, and whatever this variable is, if it matches one of these, then what's on the other side of this tipped over house gets called and returned to this variable. So in this case, I'm going, okay, check this value, which is going to be, in this case, SMA. Check this value. Since if it's SMA, then it's going to come down here, and it's going to go, okay, SMA matches I type. Let's go and return the SMA. And this is a built-in function in PineScript. Just gives me the simple moving average, and instead of placing the values in here manually, I've gone and I've used inputs just to make this statement a little cooler, a little more practical. So this is all automated here, and the source is the same for each one. Now if we come down here, we go to the options and we switch the MA type to EMA, and EMA gets assigned to iType, then the switch statement goes, okay, iType is now EMA. It's not SMA, so we don't return that one. It's EMA. Okay, so let's return that one. And it returns that value that comes from this function here into the MA, and then now we're plotting it down here. And it doesn't have to be a function here. You can return whatever you want, really. You can do that. And if you want to have a default, so if iType doesn't match anything, then you could do some default like 0 or NA. Okay, and that's like the else part of the if statements, or the last part of the ternary operator. And that's how you use switch statements, if else statements, and ternary operators, conditional statements. All right, let's talk about loops, and we're going to start off looking at a for loop here. And all a for loop does is it will repeat the same task over a period that you assign. So in this example here, I want to repeat these calculations in this local block 10 times. The way you write the for loop is for some value to some other value. So this is start for, so for I equals 0, start at 0, and then, and then loop to 10. And then if you want to, you can do like by 2, so it goes up by 2 every time, or 3 or whatever. But in this case, it's going to go from 0 to 10, and then it's going to drop down into this code block, and it's going to take whatever index we're at. This I is technically the index, and it's going to multiply it by 2. That's the calculation we're doing. So in the first iteration, it's going to go 0 times 2. The result will be placed in this variable, and then we're going to come down here, and we're actually going to plot it. So if you look up in the chart, you can see it being plotted. And first, on the first bar, we're getting 0. Second one, we're getting 2, 4, 6, 8, 10, 12, all the way up until to 20. Okay. Now loops are confusing because they're running on a time series. So this loop is actually running on every single one of these bars. So here, it's doing the same exact thing as you see here. The only reason you're not seeing these labels here and here and here and all the way through here is because there's a limit to how many labels that we can print on the chart. And we can change that by setting the argument up here, max labels count, and the max we can do is 500. And you'll see now it's going back all the way here. So now we get a bunch of labels. Now you could have it to break after if I equals 5, then break. You could have it stop at 5. There's also the continue keyword. If I equals 5, it will continue. One thing you can't do is put plot functions inside of these. So if you're trying to display some data so you can help you debug, that's why I was using the label here, because plots do not work in the local scope. Everything inside this for function that's indented here is local scope, and it cannot be accessed outside. You can't use plots inside of local scopes. You can't use plots inside of functions. So plots can only work out here. But notice I try to do this and undeclared identifier in my var. But I identified it right here. But that's because it's in the local scope. So if I really wanted to do this, I would need to assign it before I start the for loop and just call it 0, and then reassign it inside the for loop. And now I can plot it because it's in the global scope. So to create an array, there's two different ways to do this. You can use array from, and then use comma separated values like 1, 2, 3, whatever you want in here, and it will dynamically turn those values into an array. You could do a bunch of strings, maybe a bunch of different types of exchange names, or whatever you want, whatever your data source is. You could copy some data from the internet and paste it in here in this format and just create an array right off the bat. So that's one way to do it. And then you can assign it like that, like you would any variable, and now you have an array. Or you can do array new and then the type. So some of the basic types here, you have bool, box, color, float, int. And the thing is, you have to select the type, and you only can put that type in that array. So if I selected float here, it's asking me the size of the array. I could start off with a size, maybe it's got 10 slots in it, and then all 10 of those slots will be filled with a float of 1.0. However, I like to start my arrays off with NA and just have nothing inside of them. And then if I wanted to create the same array here, so this one is 1, 2, 3, 4, 5, A1. I can do the same thing with A2 by doing this, and then now this is an empty array, and then I can use this method called push, A2.push 1, 2, 3, 4, 5, and that will push those values into that array. And then you can see that by plotting the arrays. Now I can't plot the array outright like this because of the type. Cannot call plot with argument series A2. If I wanted to, I could do label new, and this will just plot a label on the bar index at the close, and I could, the text here, we string to string, and this is a quick way to plot what's inside of an array, as long as the array isn't too big. 1, 2, 3, 4, 5. And if you want to make it so it only plots in the last bar, you could do if bar state is last confirmed history. Put that inside the local block, and this will only execute on the last bar before the real-time bar. So now I can see what's inside this array. I can see what's inside of A2, I can see what's inside of A1, just like that. Same thing. Arrays are great because you have methods that are attached to the arrays that are built in. You can get the average, you can get the variance, standard deviation. There's also, let's see, if you just type in the name of your array, the variable that you assigned it to, and then you press period, you can get all kinds of different options. Binary search, copy, concatenate, fill it with the values. You can get the first value in the array. You can get the value at a certain index in the array. You can see if it includes a certain value. Does this array include 22? If it does, then do something. And the mode, the median, the max, min, percentile, nearest rank, percentile ranked. This pop will remove a value from the array. Push, we already seen that adds a value to the array. You can see the range in the array. You can reverse it. You can set a certain value at a certain index. You have shift, which is like push, but for the other side of the array. So you can put a value in the front of the array or in the back. There's all kinds of things you can do here. All these methods are attached to arrays, so it's really nice to work with arrays in this case. So accessing arrays. Arrays are 0-based, so this 1 here is at the 0 index. This 2 is 1 index. 3 is at 2, 3, and 4. So if you want to access the 4, you would want to do A2 get 3 in this case. Let's see. And let's see, that's plotting it. We can look at the data window here. Array index 3 is 4, see? And array index 0 is 1. And if you try to access an index that's beyond the size of the array, 6, you will get an error. See here? Except the compiler doesn't throw an error. It compiles fine, but you'll get this little exclamation point up here. Click on that. Array get function index 6 is out of bounds. Array size is 5. And you will see that a lot when you're working with arrays, especially when you start doing loops. Speaking about loops, this is how you loop through an array. So you could do, it's a little bit different than a normal loop. So what I did here is I used 4, and then the element in A2, before it was 4, and then I had to assign an index, say 0, 2. But I could do that, but they actually made it really easy. So now I can just grab, and this returns me the value. So I can loop through the array using this, and then I'll post some labels here at the bar index, close, and show me the element. And the other way, the normal way that we had to do this before they added the in keyword, would be the original way we saw here. For I equals 0, 2, and what we did was A2, and we did the size, so we got the size here, -1. And that will loop through the index of the array. And then we had to do label that new. I'm showing you this because you'll probably see it a lot in older scripts. And say we just draw this at the close, and the text will be A2. This is how we get the element, the value inside the array. Get, and then we get that index. Okay, and it's giving me an error because this array has floats in it, or integers. So we also, to plot a text, we need to convert any integers to a string, just like that. And we should get the same exact thing as we do here. You can't tell the difference because it's doing the same thing. And that is arrays and loops. There's also matrices, which are basically like Excel sheets. You have rows and columns. This is great if you know some linear algebra and you want to do some matrix calculations. If you want to do some Fourier transforms or find some eigenvalues, you can do that. And matrix values are assigned the same way, matrix new, into a variable, and you actually select how many rows and how many columns in the initial values and the type of matrix. And you can do the same thing to display it. So if I want to display all the values inside the matrix, I can just do label new and then show the whole entire matrix like that. And since the matrix is rows and columns, you'd have to do a double for loop. So for array element in the matrix, and then for the element in the array element. So then it loops through the row and the column. And in this here, this notation is a little bit different. So when you do for in, you can actually have it give you the index and the value that's in that array. And I don't expect you guys to understand this completely because this is more of an advanced concept, and I'm trying to make this section very quick, but I want you to understand this exists and you can use it. The whole idea is that you just understand that this is available to you, it exists, and you can use it. Personally, I haven't found an instance where I use a matrix, but I do use arrays and for loops all the time. With that noted, I'm just going to leave that there. If you feel confused, that's okay. We're going through this very quickly just so you can get up and running, and so you have a perspective, you have an eagle's eye view, you can see what's going on. Now we're going to talk about functions, objects, and methods. And to start us off, you might have noticed these little curly brackets in the script. Check it out. This is how you fold your scripts really nicely. So this function section is folded, and then we have little subsections, functions, objects, methods, examples. So you can just click this arrow. So how do they do that? Code folding, like this. And then just put that other thing on a new line, and I get this little drop down here, and now it's there. So that's that. Anyways, functions, what are they good for? They're good for reusing your code. If you don't want to repeat yourself, don't repeat yourself in your coding. I just repeated myself, but I'm not coding. Variables inside your functions are locally owned. We've seen that before. They can't be called outside the function. And it's possible to use variables from the global scope, but you cannot modify them. So let's look at a function and let's understand what I'm talking about. So this is how you create a function. Essentially, you give it a name, you make these little parentheses here, and then this little tipped over house. And then inside is your function. here I've just assigned two variables, and I like to put this underscore here before the variable so I know it's a local private variable inside there. You don't have to do that. And functions return the last line inside the function. So when I call this function, it's going to return B. Let me just show you how to call a function before we get into that. So I'm going to save this, and now to call the function, you just type it out the same way you named it with the parentheses, and you don't have to do this again. Just type it out like that, and then it's going to come through, it's going to look at this, and it's going to run this code inside this every time you have this typed out. And in this case, I've assigned it to return a result to this variable called function result, and I'm plotting that here. So if we look, function result is 2. Of course, I can call this like as many times as I want in the code, but it doesn't do anything in here that's going to show me anything on the chart. And if I wanted to do return like the result of A plus B, then I could do something like that. And now it's going to do 3. I don't even need to have it. I could have something like this. It's still going to return it. Okay? And that's a very simple version of a function. For the second example, we have parameters. And this function accepts parameters to it. So you have your function here called myCoolFunction, super cool. And inside of the parentheses, I've made 2 arguments. And one's called param1, the other one's called param2. They're separated by a comma. Same notation. And inside, we're just taking param1 and param2, and we're multiplying them. And that result is getting returned. So I didn't even bother calling it and storing it in a variable. I'm just calling it, and it's being instantly passed to the plot function. So here, I'm calling myCoolFunction. I'm passing it 10 for param1, which is getting sent to here. And then another 10 for param2, which is getting sent here. So 10 times 10, in this case, 100. And you save it, and you look, we have 100. Pretty simple stuff. And pretty cool, because now I have this function that multiplies for me. And I can sit here and I can change, what's 2 times 10? Oh, it's 20. Well, apparently I don't need this function because I can do it in my head. But obviously, things will be a little more complicated, I hope, when you're building your functions. If you ever find yourself rewriting the same code over again, that's how you know it's time to make a function. So here's a little calculator, a little multiplier. You can actually place these inputs inside of your parameters. It's not the greatest way to write your code, but you can do it if you want to test something real quick. And now I have this multiplier, 34 times 10, and like so. And here's an example showing you that you cannot modify the global variables. I said this before, but I want to show you so you get it in your head. So here's this global variable. It's just basically a variable that I made outside of any local code blocks. And I want to build a counter, so I want to count by 1 every time I call this function. And it's not going to work, right? I get an error. It's already showing me cannot modify global variable in function. So how would I do this? I could do this. I could just do global var plus 1 and then take that count and then reassign it into the global var. I also need to plot something here for it to show up. And if it's counting on every bar, why is it only 1? Well, that's because the global var is being reassigned in every bar back to 0. It's being reset every single time it runs over a bar. So we got to initialize it using the var keyword. So it gets assigned 0 once in the beginning, gets initialized, and now every single time the count is retained on every next bar. And now we're getting a count of 157. And that's how you do that. Let's talk about these really cool things called objects. Now, I briefly talked about these in the beginning when I was talking about types, and we have the 5 different fundamental types were ints, floats, booleans, colors, and strings. I also mentioned that there was user-defined types, and this is where user-defined types come in. We can create our own types, and they can be made up of anything. So what does that look like? If we use this keyword called type, we can define a type. Like, I'll call this one my bar in this case. And I press enter or return, and it drops down, tabs in 4 spaces automatically. And now I can use this and start defining some variables inside of this type. So let me just show you. I want a variable called O, a variable called C, H, L, and one called is up. Now, that's all I need to do, sort of. Now, I tried to save this, and it goes in a type declaration, all fields without a default value must be explicitly typified. What I can do here is, I know this is going to be a float, so I could type in float, and I know this one's going to be a float, I know this one's going to be a float, I know this one's going to be a float, and I know this one's going to be a bool. That's one way of doing it. However, I could have default values here, like that, because that's what I'm going to use it for, and like that. And since PineScript is dynamically typed, it's going to figure out that these are floats automatically. So I don't need to explicitly define them. And I can start this one at false. Or maybe I just want to keep this one like this. Whatever way you want to do it, that's how you do it. That's how you create an object. But what is this useful for? What does this do for you? This is where it gets fun, because if I had a function, a fun function, and I wanted to pass it a bunch of different variables and arguments, so I could do a bunch of different calculations inside the function, and it was a super complex function that did all kinds of powerful things, and I need to pass it, in this case, 1, 2, 3, 4, 5 different variables. That can get messy. And I've had functions where I've had to pass over 20 different variables, and it's not fun writing those functions and working with them when you're trying to call it a bunch of different times, or you need to change something or debug something. It's not fun. Even though it's called fun, it's not fun. In this case, I can actually do that, and instead of passing all those parameters, I can just pass this new type that I've created. And then inside of the function, I can call those variables that I've defined. Okay? This is what makes it great. Before I can do that, I have to initialize this type by calling my bar, the name of it, .new. That's the only notation I need to do. And here I can assign the values. So if I wanted to assign O a different value, like open +1 or something like that, I can do that. But since I already gave it default values, I just can call it and it will assign these right here. And it will assign it to my bar. Now, if I want to plot, I can plot my bar and I'll get the close. My bar dot. You got to make sure you're using dot notation to access the variables inside of your object. So in this case, I have the object close, and you can see it's plotting the close, which is very, very convenient. Okay? And down here, you'll see how this works very nicely. To pass an object to a function, basically, you're going to take the name of your type, the name of your object, and you don't have to do this, but it's very helpful because when you are hovering over your function later on, it's going to show you what's accepted here. And it shows me automatically that it's accepting this user-defined type, my bar. And then I can hover over my bar and it shows me, okay, it's got these fields. If I save this, it still works. But now when I hover over this, it's not going to show me the type that I can pass to it. So it's very helpful to place the type inside the function, though you don't need to. So this is the type, also the name of the object, kind of confusing. And then this is the name of the temporary argument that is going to be used in the local scope of this function, which takes the place of the object that I'm passing. What I did here is I created this, I initialized it. In order to use this object, you need to initialize it. Now I have my bar. You can see I'm plotting the close. And then down here, I'm taking this same variable that I initialized and I'm passing it into the function. And then that's where it pops up here. It's called bar now. And then I'm checking, okay, because remember we created this variable called isUp. I need to use the reassignment operator. And I'm just doing, okay, is the close greater than the open from this object I passed. If it is, then isUp will be true. If it's not, it'll be false. And then I return the entire object. And it shouldn't be my bar, it should be bar here. So I return that object when I'm done, and then it also gets reassigned to the original object, because this is just a local object. And then now I have my bar here, and if I wanted to, I can plot car and do my bar dot is up. And it's probably not helpful that I've named the variable of my object the same name as my object. It's kind of messing with the compiler. So I'm going to call this my bar. It works, but it's also confusing because it's not unique. So here we go. So in this case, the reason I did that is because now I can press the dot notation, the period, and it's going to pop up with all the variables inside of this object. And there's isUp, and it's going to plot every time there's a green bar. And that makes life way easier. And if I wanted to, I could have done this. Maybe I want to get a new bar. I can call that object with inside a function. Just do my bar new, and then it returns the bar. So instead of initializing it outside, I can initialize it inside a function. And that's objects in a nutshell. They are so powerful, so I recommend you start to work with those, and you're going to find that they make life very, very easy. Now let's talk about methods. These are also really fun. Methods are pretty much just like functions, except once you make a method, you can call it using the dot notation we just saw with the objects on your variables. So how does this work? You use this method keyword before you write your function, and then I can just go ahead and I can call this function, aka method, on this variable. So all these variables really are just objects. We've seen that, and they're just objects of different types. And this in this case is a float, right? 0.0. So we know this is a float object. And now I'm taking this float object, and I've created this dot notation method, which is attached to this float object now, and I'm passing it 1. Now you notice there's 2 parameters here. The first parameter is the object that you're calling it off. So automatically it's going to take 0 here as a first parameter. And then the second parameter is this one here, which is being passed here. So now I'm doing a plus b, so this should plot 2. So I save this, and I get 0. Oh, you know why I get 0? Because I called this, and it's just running this, but it's not returning it to anything. So really, it needs to be reassigned. Or I can just do it in here, inside the plot function. There you go. Now you see 1, because it's actually 0 plus 1. And if I wanted to make that work outside of the plot scope, you would just do this. There you go. Nope, capital F. Bing bada bing. So, method and functions are exactly the same thing. The reason why we call them methods is because they are attached to an object. Otherwise, they're pretty much interchangeable. Functions, methods. And if I wanted to use this method on an integer, say it was a 0, it's not going to work, because it only works on the type of the first parameter of the method. And you see here, you have to actually assign the parameters inside your methods. That's the other thing with methods that make them a little bit different than functions. So this wouldn't work. I need to be explicit about how I assign the parameters. So if I want this method to work with integers, I need to change this to integers. Well, the second one could be a float. It can be whatever you want. Okay, now let's look at another example here. And let's see. This one gets a little complex, but bear with me here. We're going to make it work. So in this example, I have created a type called types, and I just put in all the different types that are available. And now I want to say I want to do some debugging. I want to plot some value on the chart, and we saw earlier if I want to plot a boolean, I need to do plot car, or I need to use the ternary operator If I want to plot a float, I can just use plot. But also if I want to plot inside of a function or some local block, I need to use a label. So debugging can get a little complex because you got to remember all these different things. So this function right here solves that. It's just called show on chart. It's a method, sorry. This method shows that. And then the object that I'm passing it is called types. So what I'm going to do is I'm going to be working and, okay, what's this variable? And I'll assign it to this object, and then I'll pass that object to show on chart method, and it will display to me what that object is, or what that variable is. It's going to go, this is this types. That's the object I'm passing it for the parameter. It's going to go through. It's going to create a empty variable for an empty message that will be used later, and an empty label that will be used later. And then it's going to use an if-else block, and it's going to check if this object dot notation int, if that's a, because by default these are all going to be NA. They're going to be not values. So this is going to go, if it's not a value, then it's false. If it's not a value, then it's false. So if these are both false, then it's going to go to the next one. And if the bool value that I assigned to it is true, then if this bool is true, then return the text true to the message variable. Or reassign it to it. And if that's true, then it's going to drop all the way down here. And on the last bar, it's just going to display a message with whatever we put the message as. In this case, we want to check this random variable. Let's just make it less complicated. Say it's the close. But obviously we know what the close is, so we wouldn't need to check that. But say it's more complex than that. And the first thing we need to do is we have this object that we created, the types object that contains all the types. We do types new, and we can assign the float value, the float variable, to some random variable that we want to check. And we know it's a float. That's the only knowledge we need beforehand. We need to know what type it is. We assign it to float, and then we assign that to a variable. So now this object is here, and then we can pass that object to show on chart, and it should show on the chart. Here it is. So there, shows the value right there. And methods can also just be used as standalone like this. You can pass some functions, just like functions, or we can use the dot notation on the actual variable here on the object. So just like that, that's how you check. And now what if I assigned it a boolean, and instead of assigning the boolean to a boolean, we could do bool, some random variable, and it's going to tell me if this boolean is true or false. So it's true. And we could do a string. So this is just a great way of checking your values if you're debugging. Well, it's not the greatest way, actually. There's another way to do this that's a little more complicated, but it's easier to use. So once you set it up, you're good to go. And if this was confusing, you're gonna like this next example. So it's the same thing, but just written a little bit differently using method overloading. So let me show you how this works. Functions and methods in PineScript can be overloaded, and that means we can write the same exact names. The method names or the function names don't have to be unique if you're writing them like this. I can have the result be different based on the type of parameter I'm passing. So I've created this method. It's called show, and the first parameter is an integer, a, and basically it's just going to wait until the last bar, and it's going to return a label at a specific time on the last bar at the high, and it's going to convert that integer to a string so I can see it, and it's just going to put the text a little bit different. But if I pass it a float to the show method, it's going to run through this method. If I pass it a bool, it's going to run through this method. And they're almost identical, except when you get to color, it's going to show you, okay, now this is a color, because I can't display the text of a color. And actually here I'll change the color of the label. And this one, if it's a string, I don't need to use the string convert. It will automatically just label the actual string. And you can see now that this one method now accepts every single different type. So now all I need to do is, I had this random variable, it could be 1 for all I care, and now I can go, as I'm trying to debug, I could be inside some local scope. If the close is greater than 1, or greater than 0 in this case, I could be like, okay, what is this random variable that I've assigned? What is that? And I can use the dot notation, and it will show me, oh, that's the variable. That's what that is. But what if, in this case, it's a float, or it's a string, in this case? I've already overloaded this function to accept strings. So now it's accepting strings, and it's showing me what's there. But what if it's an array? You can see down here, I've actually set up some code to accept arrays. Accepts arrays, floats, and strings. I didn't do all the different types of arrays because it's just a lot of repetitive code. But I probably will. Maybe I'll create a library for this. I can do array from, and then do, this is an array of strings. Hello, world. And then now, I'm like, oh, what's in that array? Random var show. And now it's showing me what's in the array. I don't need to write all the other code that we went over earlier. It's just this dot notation will always be available to me as long as I have these methods somewhere accessible in my script. Now I can put these in a library and import them from the library later on, so I'll always have this dot notation to help me debug or whatever it is I want to do. And that's super helpful. So that's how I would write that, and that's the power of methods coupled with overloading and objects. Very powerful things. Learn how to use those and you will be mastering PineScript in no time. I just want to go over some quick things that I use to efficiently write code, and I hope they will help you. The first thing is the Option key on your keyboard. Now on a Mac, they call it the Option key. On Windows, it might be the Alt key, but you basically hold it down, and I'm using the arrow keys, and I can just skip between entire words instead of going letter by letter. Now I can do the whole word. Okay? And if I hold the Option key and I go up and down, I can move this line just like that. If I use Shift in the Option key in the arrows, the up and down arrows, I can duplicate lines like this. Very, very helpful. And finally, if I hold the Option key and I use my mouse, I can click and then click again and again and again. I gotta make sure I'm clicking on the right spot. But basically, it'll drop a cursor wherever I put the click at, and then now I can do multi-line edits. And if I'm holding the Option key and deleting at the same time, it'll delete whole words, just like that. And that's the Option key. That's the power of it. It will speed up your coding and editing very fast. This next one was plot debugging in the data window. I don't need to show you guys this because I've been showing you the whole time. Basically, if you're plotting some variable, you give it some title, you save it, and instead of trying to look for it somewhere on your chart, maybe using these up here, you can just go to this data window, and then here it is over here. But we've seen that before. You can also, in version 5, there is this parameter called display. So if you only want it to display in a certain area, you can have it display in just the data window, none, in the pane, price scale, status line. So sometimes I'll just do this and have it go in the data window. And then finally, there is another option for debugging, but this is more for like if you're writing a public script. I mean, you can use it for whatever you want, but it's useful in like a script that you want other people to use. If you're doing something that they shouldn't be doing, you can have the script completely stopped and give them an error. This is one way to do it. And you could have like, if person is using this script wrong, and that's your variable name. So let's assume that we're using the script wrong. Then you drop in this thing called runtime error, and you got to give it a message. That's the only thing. Hey, stop what you are doing. Save that, and now this will pop up. Error on bar 0. Hey, stop what you're doing. Okay, cool, thanks. And if you want to make it better, you can do string format, dot notation, format, and then encase this entire message, and then you could format some kind of variable here, and then your variable will be like the close. And then now it's going to tell you the value of the close on bar 0. Well, it's 0. Or your variable could be var equals 120. Instead of having that, it'd be my var. And that's how you would kind of debug another way, or just display messages to your users. Now, you're going to run into a lot of errors, and I can't cover them all. These are resources that you can check out for commonly made errors. The one I like to use a lot is the Pinecoders one. That's made by the developers of Pinecode. They have a very good list of different errors and what you're possibly doing wrong. The compiler itself is a very good resource, so pay attention to that. One thing I would like to note about the compiler is if you have an error, it's going to show all of your errors, right? Here's this and this, and then maybe you're using p in your function. The point I want to get across here, p actually works just for some reason. Sometimes it'll give you a big list of errors. Just scroll up and go to the first error that it gives you, because sometimes that's the one that you need to fix, and once you fix that one, all the other errors are fine. So those are the hints and tips on the debugger and using the option key. I hope you guys like that, and I hope you do something useful with it.
What's up, everybody? You enjoyed this mini series. You will love the rest of the course, because this was actually taken from a larger course that I have called Practical Pine Script. And in that course, we take what we've learned so far and we start to build indicators and strategies and live automated training strategies that will run on a live exchange. So with that course, you will get 4 more sections. We got section 3, which goes over all the built-in functions, technical analysis, multi-time frame analysis, auto-focusing, multi-time frame dashboard, many different types of indicators that I have developed. I go over them for you. In this lesson, we actually break the security call limit of 40 security calls. I get it up to 500. And then there's a bunch of other stuff here. You can check it out on the website. With this course, I include a couple of tools that I've made that I have for sale on my website, but you get it for free. You also get direct access to me and the Discord group. So that being said, the price of the course currently right now is $40 US. But since you're here on YouTube, I want to offer you guys a discount. And all you have to do is just leave me a message in the comment section, and I will send you a huge discount. So thank you again for your time, and I'll see you in the order books. Peace.